Sir, shall we start the session, sir?
Yes. So shall I share my screen? Hello?
Yes, sir.
Shall we start?
Yes, sir. I extended a warm welcome for all the participants of Day 9 Session 2 on FDP AICTE sponsored faculty development program on machine learning in image processing applications. And it's my privilege to introduce today's speaker, Dr. S.N. Omkar, sir. Sir, thank you so much, sir, for accepting our request. It's my fortunate to introduce Sir, Dr. S.N. Omkar, sir. Dr. S.N. Omkar is the Chief Scientist in Indian Institute of Science, Bangalore. He completed his BE in Mechanical Engineering from Bangalore University. He completed his MSc in Aerospace Engineering from IISc Bangalore and PhD in Aerospace Engineering from IISc Bangalore. He is a founder member, treasurer of Atomic Control and Dynamic Optimization Society and a member of Indian Society for Advancement of Materials and Process Engineering, Indian Society for Remote Sensing, American Helicopter Society, and a research advisor of Tata Consultancy Services and member of review committee on proposal on land resource information system for the state of Karnataka, and a member of detailed design review, development of fixed wing micro UAV ADE and review of R&D projects, development of fixed wing micro UAV NAL, and he is a reviewer for various IEEE conferences and reviewer for various journals, and he is a PhD thesis examiner for Madras Institute of Technology, Chennai, and Geetam University and Dr. MGR University, Chennai, and Jawaharlal Nehru Technological University, Hyderabad. He has won 5 Best Paper Awards for his research papers. He was a session chairperson for Asia Pacific Congress on Sports Technology held in Tokyo and third International ICSC Symposia on Intelligent Industrial Automation and Soft Computing, Genova, Italy, and Asia Pacific Congress on Sports Technology held in Singapore and Global Technology Advancements, both Asian Australian Rotorcraft Forum, Bangalore. And his research interests are helicopter dynamics, satellite image processing, biomechanics, uninhabited air vehicles, autonomous navigation of UAVs, composite design optimization, and structural health monitoring. Now I request Dr. Omkar sir to take over the session.
Okay, thank you. Now can I share the screen?
Yes, sir.
Okay. Let me see how do I do that. Yes. You're able to see?
Yes, sir.
Go to presentation mode. So thank you for the introduction. So I understand this is the AICTE session on. So today we are going to talk about machine learning. Okay, then this PSCMR CET Vijayawada. So yes, I visited Vijayawada quite a number of times. Well, now it must be quite hot in Vijayawada. Hope you are in a cozy environment, and that too after the lunch. So I'm sure the participants will be able to focus. So I'll be speaking on machine learning and deep learning in image processing. Well, this is about why I have taken this slide is that there is tremendous application today in unmanned aerial systems for agriculture, and ours is agricultural country. Therefore, I have projected this, and this will also contain a lot of other things. You see, on top you have the satellite, and then you have the manned aircraft, then you have UAVs, also you have mobile phones. Through all these things, you can acquire images, and all these images you can use ML and DL algorithms to do a lot of image processing. So that's why you can choose any of these things, and most of these we have used in our research work. We have done a lot of work on satellite images. If time permits, I will take you through that. Then some work in mineralogy, when we talk about the fixed wing aircraft. Then on UAV or the drone image processing, we have done a lot of work. On mobile image processing also, we have done quite a few work. So in all these cases, ML and DL are very helpful. So this is the overall definition of the broad umbrella of artificial intelligence, which actually consists of both machine learning and deep learning. So this area, this word artificial intelligence is maybe more than 60 years old. This idea came up long back, but there was some sort of recession in these studies during, I think, 1970, when a book called Perceptron was published. And then in 1976, there was a paper published by Rumelhart and their group on backpropagation algorithm. That actually was a big game changer. So that changed, and then the artificial intelligence developed a lot. Then first it came as neural networks, then several modifications came. So now all these things come under the umbrella of artificial intelligence. Machine learning is a subset of AI which use statistical methods to enable machines to improve with experience. Whereas deep learning is a particular kind of ML algorithm that is inspired by functionality of the brain cells called neurons, and which essentially is ANN or artificial neural network. So this is what it is. The definition broadly is a computer program. It set to learn from experience E with respect to some class of task T and a performance measure P if learners performance at the task in the class as measured by P improves with experience. So whole idea is that it should improve with experience. So one of the informal definitions is machine learning is the science of getting computers to learn and act like humans do without being explicitly programmed. So if you look at here, traditionally you have data, you have program, and you have computer which executes your program, gives you the output. In machine learning, you have data that is the input and the output, and then the computer is there. The computer will generate the program, which means the computer will know, or the algorithm will help you to discover the model that connects the input and the output. So deep learning is a subset of machine learning, utilizes hierarchical level of artificial neural networks to carry out the process of machine learning instead of some statistical methods. So deep learning, you see, is designed to continually analyze the data with logic structure similar to how human would draw conclusions. So how he learns from experience the same way. So artificial neural network and a number of variations of that are an example of this deep learning. So this is the essential difference between deep learning and machine learning. You just see here very briefly. Suppose you want to classify this as a car. So this is the input, and feature is extracted. What do you mean by feature extraction? It has 4 wheels and some kind of shape, and then the classification algorithm will give you the output. Whereas in deep learning, you do not do any feature extraction by yourself. There is no teacher that is involved. It will extract all the features by itself and will do the classification. That is deep learning. So now we will look at some of the examples, what we have done in our lab using these in terms of the drones and some other applications. So this is one example of a drone, where suppose you want to fly your drone in an environment like this, which has a lot of trees. Obviously, obstacles should be avoided, and maybe there is no GPS. So it is purely vision based. So how do you do that? You have a small computing platform called Android on your drone, and there is a monocular camera only. So you have to design an algorithm. So we have done. So this algorithm is based on supervised learning. This is called texture-based algorithm. And this is our IIC. You can see the drone moving autonomously. On your right side window, you see how the algorithm works. This is called texture. What this does is, this will calculate the texture based on the camera as to what is the kind of tree or whatever obstruction is there. And it will find out this yellow thing at the minimum resistance area through which the drone moves. So this is one simple algorithm we have developed, and we have extended this algorithm by another method. So that also I'll show you. So this is the texture-based algorithm. Okay, then this is called the optical flow algorithm. So it will compute the optical flow vector based on whatever obstruction is there and find out the correct path. This is autonomously flying. No one is controlling this. There is a small computing platform that is sitting on this. The algorithm is also very light, because if it is heavy, you cannot fly it real time. So we are doing it real time flying. There is no computer or nothing. It's just a Android board sitting, which is computing, and there is just a monocular, similar to your webcam, not a sophisticated camera. There is no depth information, but still it would work. So this is our campus. You see a lot of trees. So that's how it works. So this is the optical flow method for obstacle avoidance. And you see there are cases like this, pathways. For example, if a military convoy is moving in a forest, and you would like to know what is ahead. Is there any threat, danger, etc.? Or if you go to an unknown forest, you don't know what is there, and we're all there, and you want to know what is there. So in such cases, we can send a drone. You don't even know how the path is going, but you know there is a pathway. So now we have developed an algorithm. Again, is the downward looking camera on a drone, which will detect the road by head detection algorithm. It will center to the road, and it will keep moving as far as you want along the road. Of course, it is limited by the battery availability or the endurance of the drone. So this is called road identification algorithm. This is what we have developed. You can see here. This will center to the road and keep moving. This is also our campus, and it is moving at a good speed of about 40 km/h. So that is the speed at which it is moving. So these algorithms are developed in-house. And yes, if you have a drone, a camera, and a simple computing board, you can also do this. The whole purpose of me giving a talk for engineering college is that we want to encourage students to get to do some things. See, today we want youngsters to develop that skill of doing things. And in engineering colleges, sometimes it is completely missing. So that is not a good trend. So students should take interest, the faculty should take interest to implement something, whatever it is, even though something existing, it may not be completely new. It may be some already existing idea, but that culture of doing things should come. So that is the purpose. So this is another algorithm. Then we look at autonomous landing. Say when in the drones take off, we want them to land autonomously. So there are various situations, as in, for example, you want to you want to take off from a car, go do the surveillance and come back and land on the top of the car. So we have done that. It is gone. So this is purely based on GPS. See how it comes. It's purely based on GPS. And then it perches on to the top of the car. Now there are two issues here. Issue number one is that the GPS is purely based on GPS. So which means purely based on GPS, which means the GPS accuracy matters. Today, the GPS accuracy is plus minus 2 meters. The best you can get. Sometimes only you can get 2 centimeter accuracy. That day when we did this experiment, it's by luck, we were able to latch exactly onto the top of the car. So always it does not work. That is number one. Number two, the car is stationary. So it is not moving. But generally we want it to move also. So first, we have to overcome the GPS limitation because GPS has limited accuracy. Now what we have done is here, oh no, this one. What we have done here is we have made what is called a QR codes. So codes we have developed. Now this will go fly away. Through GPS it will come somewhere nearby, plus minus 2 meters. Then the camera sees the launching pad. Then it will, based on the codes, it will land on the launching pad. So we have used the so-called the markers. So there is a downward looking camera which will see, and these codes, there are 1 at 4 at the corners. You see our computing, this is the onboard computer which is showing you the right bottom one, that is showing you what are the computers that are going on. Then these 4 markers will direct the drone to center to this marker, and then drone will gradually latch on to that center marker. See, that's how it does. So what the next one to be solved is when the platform is moving, what will you do? Because we want, for a situation like this, when I'll tell you, you have an ambulance, on top of the ambulance you have a drone. Suppose the ambulance is caught up in a traffic, and traffic can go kilometers long. We don't know. Even the sirens of the ambulance may not be heard by the police in the traffic. So a drone can simply take off, maybe alert the traffic police to clear the way, and then as the vehicles move, the ambulance will also move, and it can come and latch on to the moving ambulance. So ambulance, when it is moving, can it dynamically detect and land. So that is the idea. So this is also useful in places like Uttarakhand, where there are a lot of landslides. So you don't know whether landslide has taken place or it is about to take place. So if you can send a drone from your vehicle, it can go get the situational awareness and you can keep moving in the safe way. So similarly, it can be used by military. So it has a lot of application. So you can see here, we developed our own ground robo just for illustration, and same QR codes are used, and the drone comes and approaches and lands on the platform. So this is what we have done. The next one is, when you have a slopy terrain in agriculture, now it is very difficult to fly. Very difficult means if you simply go from the top, you will not get the images properly. I'm sure you understand. From the top, if you are looking, you are getting the projection of this. That is whatever is the slope, cos theta, that projection only you are getting. So actually, if you want to know what is here, the drone has to fly like this, along this slope, and then like this. Hope you see the cursor. So flying that way is not always easy, but an expert can fly like that. So what we do is, you get an expert, you make him fly in these terrains, so you can get the input of the pilot, what input is giving, and you can measure the output of the drone. Using this input and output, you can develop a deep learning algorithm which will imitate the pilot. Next, that algorithm will act like a pilot. You simply put it on the drone, it will work that way. So it's called imitation learning. So there are various ways of doing this. You can see this is imitation learning. You have to create a data set by flying it in various roads or whatever, wherever you want to do that, or you can also use some gaming videos, which, like a car moving in various direction, that games that you have, video games, that also you can use to create the data set for training. And you can develop algorithms to just imitate that learning. So this is what we have actually tried. So I will, because of the long video, I will cut short. And of course, this is another thing which is useful in agriculture. You see, once you can fly below the tree, sorry, this is called as the nanomister. So you want to go to a particular leaf or particular plant and put some nutrients. So in such case, that algorithm can be put onto this, and it will have a nanomister which will carry the vitamins, minerals, or whatever. I'll just fast forward. So I can see that is the mister. Yeah, see, that is the nanomister. Okay. Then we have done some work in agriculture, paddy field in Kerala. See, in all these things, a lot of algorithms can be developed because Vijayawada is also known for I think rice, mango, etc. So you can take a drone, fly on a paddy field, get the pictures, mosaic them, create one picture, see the leaf architecture, leaf color. What can you find out? So we have done this in Kerala. What we have used is a fixed wing, like this fixed wing, and we used a camera which is a 5-band camera, multispectral camera. Apart from RGB, it has red edge and NIR. So we have flown this over several hectares in an area called Palakkad. You see all these things, waypoints, everything from your Google Maps you can do, and then you can create this pattern, lawn mowing pattern. This is the path followed by UAV. It won't exactly go like this because the turning radius, everything is involved. So you collect the image, you mosaic the image, and you have different data sets. Now by looking at different bands, for example, this red, green, blue, NIR, and red edge. How do you use all these things for various, to find out various parameters like the non-dimensional vegetative index. There are several things that are possible which can tell you about the health of the crop. You can do all that. So these are some of the examples, what you can do, what all you can calculate. Of course, we will not go into these things, but we have calculated this NDVI, normalized difference vegetation index, by which you can know whether the crop is healthy or not healthy. So these are different reflectance patterns look, and these are some of the indices that you can compute, and you can use machine learning algorithms to extract the features of all these images. So we have calculated on the NDVI. We were able to find out what is a healthy crop, what is diseased crop, and we have verified through proper ground truth that whatever is detected as diseased crop is actually diseased. So that means these techniques will help a lot. Then we have used on the tomato yield, and this is the tomato image taken from the UAV. Then we have used several techniques. One we have used is the self-organizing maps. We have extracted the tomatoes from this image, and you can see the extracted image extracted from our algorithm is overlaid on the actual image, and you can see most of the tomatoes are captured, which means from a given scene which is taken from UAV, we can compute the number of tomatoes, which means we can calculate the yield of the tomatoes. But we can go further where we can actually detect the tomato as an object. That is the power of machine learning algorithms, which means the tomatoes can be picked up as an object. So that is what you see here. In this picture, you can see the tomatoes are picked up as an object. You can see the boxes around the tomato. The boxes are put by our algorithm. It's a deep learning algorithm where we have trained the algorithm for these tomato identification, and the number of boxes are directly equal to the number of tomatoes. And another important thing is that the size of the box is proportional to the size of the tomato. Another important thing is that the texture of the tomato is given by the RGB, that is red, green, blue. The texture is indicated, which means you can actually grade the tomato. You can not only calculate the what you call as the yield of the tomato, but you can also grade the tomato. Once you grade it, then you can, this is another closer look at the images. You can actually further grade it. We have gone one step ahead where we have used some mobile technology for doing some of these things. I'll show you later. So this is the power of the deep learning architecture. So once you fly the drone, you know what is the yield that is expected, what is the grading of the tomato, and you can upload this. And perhaps in future, when you can have everything on the cloud-based architecture, you know this is the yield, this is the grade, and the buyer can look at and directly contact the farmer for purchase. So this will avoid the middleman. It will help the farmer. That is the whole idea. So this is what newspaper also wrote about our algorithm. This came in Deccan Herald. They were in other news magazines also. This algorithm was covered. We have also published a journal article on this. You can go Google my name and you can read the paper. Then this is the tree crown extraction. For example, if you are in a, if you want to know what kind of forestry do exist, you can fly the drone and do what is called a tree crown extraction. Based on, because each tree type will have its own reflectance pattern, or the spectral signature will be different. So you can use several algorithms, maybe neural networks based. They use several algorithms, and then you can classify and you can get the results. As you can see, this is what you get from our algorithm. So you can do over a forest and identify what types of trees are there, etc. Then in the trees like banana tree or the coconut or coconut, etc., you can develop algorithms to actually obtain the number of trees there. So this is what is called as ELM, what we have used, extreme machine learning algorithm. It's a type of neural network which is a single pass. There is no training that is involved. So this is another possibility where you can use machine learning. Then mango, I know Vijayawada side, a lot of mangoes are grown. I have a good friend, my name is Satya Sridhar, who sends me mango every year from, I think, Beganpalli, if I am right, Beganpalli mango or something. Very sweet little mangoes. So mango is a very important commercial crop in our country. So what we have done is you can take the images from the drone of the whole mango grove, and you can also take some close shots of the mango tree. You can compute the number of mangoes that are there. Again, the size of the mango, the color of the mango, everything can be detected. We have used what is called as convolutional neural network for this. So it's a multi-layered architecture. For those who are aware of deep learning, you will understand what we have done. And see, this is how the mango is extracted at different, because there will be multiple layers, how multiple images are extracted, and finally classification is done. That the mango detection is done. So this is the original image of the mango tree. Then you can see the detected mangoes. If you closely observe, you can see the boxes around the mangoes. So those boxes, the number of boxes equal to number of mangoes, and the size of the mango is proportional to the size of the box. So it's as simple as that. Then the whole idea is now, if you can also find out, because the number of mangoes ultimately depend upon the extent of the tree or the tree canopy, what you call tree canopy will, for a tree canopy of this size, you know what is the number of mangoes approximately. Now the whole idea is, now how do you find out the tree canopy itself, number of trees and the extent of the canopy you want to find out. For that also we have developed an algorithm. This is called as the semantic segmentation using GAN, or generative adversarial network for mango tree crown detection. So that is what we have done. So this essentially will partition to simplify the change representation. It will take out from this, for example, this These two, we want to look at the chain, we can see. So these two are moving and this is stationary. So these two I can detect. So even here, this is stationary, this is moving. So I can detect what is moving. So the chain detection is possible here. So we have used a uh, architecture like this, which is generative and adversarial network. And these are some of the intermediate results. As you can see, I'll show you the final result, how we can detect. So this is the original image, and this is the detected mango tree crop. So you can see here, so you have detected everything, marked, and you can find out the extent of the canopy, and therefore you can compute the yield. So this is the actual um, mango like architecture we have used. These are all multiple layers, so don't worry about these things, but it does help in doing a lot of useful societal applications like this. Then we have developed another algorithm called eye in the sky. See, the whole idea is that this is the drone surveillance system. Today in our country, we have a lot of protest, burns, it's going on everywhere, and drones are being used to monitor if the crowd is behaving properly or is there any violence. So you can be flying maybe 20, 30 drones, and they may be sending the video feeds onto your uh, computer screen, but you cannot expect someone to be looking at the screens and understand what is really happening. It's very difficult, humanly impossible. But we have developed an algorithm which will automatically detect through the video processing in case there is any violent activity that erupts in the crowd. So that is the important thing. So this was presented in a very reputed conference in 2018, and this attracted a lot of appreciation in the world of image processing. And we were also interviewed on British Broadcast Corporation, BBC, for our work. So I'll just take you through the brief. The whole idea is that any suspicious activity you should detect. And suspicious activity, you can define what it is. So this is the work done with me by my student Amarjot Singh, who happens to be in the US now. So this is the context. There is riots taking place and some sort of chain snatching or protest like this, or some stabbing, kicking, punching activities can be there. Now, can you detect these kind of activities in real time when the drone is taking the videos? That's the idea. So that is quite possible to do that. The image processing algorithms can help. So you can see this is our airstrip at IISc. We have an airstrip, and these are our students, because we have in our lab a lot of students. At any time, we had about 40 students in our lab, and they conducted a mock drill. Mock drill means because all our image processing algorithms do need a lot of data sets. So we ask them to mimic or act like punching, dragging, pulling, hitting. So that's how we created the huge data set, and then we used that to test and train and test our algorithm. So these are some of the features. So this is the algorithm, overall algorithm that we have developed. So there is a situation where some activity is going on here. Then what are the steps that are involved? First one is human detection. Using the feature pyramid network, we use a network for that, because detecting the human is very, very important. Because in a scene, if two dogs or bulls are fighting, you should not pick up as though there is some violence activity. So you have to first ensure that it is between the humans. So once you know it is between humans, then the next step is pose estimation, for which we use a deep learning network. As you can see here, it has a very layered architecture, and each layer picks up some particular uh, stances or how they are engaged in any sort of violence activity or otherwise. So that will help us to know whether the activity is violent or not. The third step is to look at actually the orientations between the two. If the orientations are simply that one patting on the back of the other or one putting his hand on the shoulder of the other, then we are not worried. So this orientation analysis is very important. So once you do that orientation analysis by the pose key points, then you can use any algorithm. Here we have used what is called a support vector machine to classify whether it is violent or not. And the other feature of this is that you can capture multiple events of violence from any given scene. So it is not just one, multiple scenes also, multiple scenes of violence it can pick up. So some results are here. So this is what is important is these drone surveillance systems can detect one or more violent individuals from aerial images in real time. So that is the basic information. And what we have created, aerial violent individual data set, can benefit other researchers. So this came in BBC, your interview. You may not get the audio, but just I'll play it for maybe 30-40 seconds. Okay, so this is about that algorithm. Then the next algorithm we did was about disguised face identification. This is also based on deep learning, and this is before COVID. Then we did not know that we have to wear a mask. At least in our country, we are not used to that. Normally, any healthy individual would not really wear a mask. Those were the days. Whole idea is that even if you wear a mask, hat, and spectacles, the algorithm is able to detect who that person is. So we used what is called as 14-point architecture, and these are all our lab students who wore different types of masks. Masking means just not the mask on the mouth and the nose, but also the eyes. And we have also tried where a girl would wear a mush and a beard. So all that we have tried with the masks. We have trained our algorithm. So this was also figured in BBC. So we had a 14-point architecture. We get those distances. Once you train, see, complete masked. This is actually a girl with the beard and mush, but still we are able to detect. So we developed our own data set. You can see this publication also on the web. Then this is, of course, this is not our work, but I would like to show you a wrong application or a negative application, but nonetheless, how powerful can technologies become? So whatever is shown will be shown in this video. Although this is from a short film, what I would like to emphasize is that this is something that we can actually implement. We have drones, we have face detection algorithms. So it is quite easy to implement what we are going to see in this short movie.
But we have something much.
So you can see a small pump top drone. That is actually AI enabled. It has vision cameras that will detect the obstacles, that can do image processing, that can detect a face, and it can carry a small bullet. And now you will put a bullet, and there is a mannequin there. You will see that, and it has to detect that mannequin and hit the bullet. So face recognition. So what I am saying is, all these algorithms are there with us, and whatever you are seeing here is a possibility of disguised face identification. So it detects the face and it hits. So this is one of the applications. Of course, this is not a good application, but nonetheless, you should understand the technological possibilities. Then I'm going to show you one more uh, aspect. Today we are talking about drones everywhere and rogue drones. Rogue drones means drones which may create some problem for you. In the sense, it can carry some dangerous things into your campus or any critical places, or it can carry a camera and can capture all the images. And privacy is very important, and we should not allow others to intrude our privacy. So anything that violates these things is called a rogue drone. Today, this is becoming very, very important because drones are ubiquitous. Everybody has a drone, and drones can carry some armaments, some explosives, etc., which can cause danger. How do we detect drones? How to neutralize them, how to tackle them, that's a different thing. But at least you should know that some drone is approaching you. What we have done is we have used simple camera. Of course, this has a lot of limitations because the range of camera itself is a critical parameter. But if we have sophisticated camera, and if you can use those images, again here we have, for various drones, we have trained a machine learning algorithm, and see the box that's put by our algorithm. So it will detect the drone that is approaching us. So even here, machine learning algorithms can play a vital role. Another application of deep learning methodologies. So this will be useful in all critical structures like airports, some defense bases. We would not like any drone to intrude and play a spoil sport. Then look at the detection and rescue of flood survivors. This is another area of importance. There could be a lot of floods. how do you handle the survivors? Generally, what happens? Generally, the rescue authorities do not know how many survivors are there, where, how many homes are damaged. These things are not known. If you are able to fly a UAV, get the image, and identify the humans, the animals, etc., that are caught up in the flood, then it is easy for, because you will get everything with GPS tagging, and you can reach that place. I recall that during recent floods near, I, I think, Coorg or somewhere, there was some rescue operation going on. Some people were caught up. The rescuers thought there may be few need to be rescued, so they sent a boat which can carry 8 people. But they found that there were 80, and there are a lot of people because everyone wants to get into the boat. So there are a lot of difficulties in convincing them. It was already evening. See, decision making becomes very critical. Had they known earlier, they could have arranged a larger boat, etc. So situational awareness becomes very, very important. So even here, you can do use machine learning. We have used what is called as region-based convolutional neural network for this object detection. We can detect how many people are there like this. Okay, even animals we can detect how many or what kind of cattle or animal is to be rescued. So here is different scenes. Somebody in the water, some people stuck in the water, some people walking in the water, some animals, some people caught up on the rooftop. All that can be picked up. So this will help the authorities to take appropriate action. So that is the idea of this. Then we have done something using mobile phones. But before that, if you have any questions on these things, because already 3 o'clock. So far, whatever we have discussed, any questions? Hope all of you are awake. No response.
Yes, sir.
Yeah, I was wondering whether you have left me alone and disappeared. Any questions? Please, I would be happy if somebody responds.
Yes, sir. We are able to hear you, and the presentation is going good, sir. Continue.
Flight Lieutenant Kishore is always to help me.
No, sir. This is the time that it is unmuted. I think other participants can ask questions.
Yeah. Any of the faculty, you would like to have some interaction? Don't hesitate. No question is small question. Every question will be honored, if not answered. Where Dr. Ravi is there, huh? Hello. ఎవరైనా మాట్లాడతారా?
Sir, no queries till now, sir.
At least they should tell, no? Which means either I'm doing very well or they have not understood anything. Anyway, we have done some work with the mobile itself. We took up this sugarcane leaf disease detection. Why sugarcane? Because India is the second largest producer of sugarcane in the world, next only to Brazil. And also near our area, Mandya and Mysore district, sugarcane is a very, very popular crop. So for everything, you cannot depend upon drone. Idea is, okay, many of the diseases can be detected visually by an expert. If an expert can detect, why not create a deep learning algorithm which can behave like an expert? That's the idea. We conceived of this architecture. There is a mobile phone. You click 3-4 pictures of your sugarcane leaf and the stem, upload it to the cloud via the internet, and on the cloud is a AI-based image processing, which means deep learning based image processing, which will tell you whether your crop is healthy or not based on the image, and it will send you the information to the mobile phone instantaneously, of course with the solution also. This is what it is. You input image and you get the result. These are the 5 different diseases, very popular ones we considered. I don't want to read each of those things, but these are supposed to be the very common diseases for the sugarcane plant. You can train an algorithm to detect these 5 diseases. Of course, you have to generate huge data set. Once you do that, then this is the layout of the app. We have made an app also, an Android app. You can just click on the image, upload, and then ask it to detect. It will detect. I'll tell you what it is, whether it is a healthy crop or not a healthy crop, what kind of disease, and maybe a possible solution, what action you have to take. Then you can also, through the same algorithm, do the area estimation of your plot. It's a very simple GPS application. So once you know the quality of the crop and area of the crop, you know generally what is the yield and what you can expect from the outcome of that yield. Then based on the mobile, again, we wanted to look at how do you do image processing to identify bad tomatoes and good tomatoes. There are data sets available. So our student used all that. We used again a CNN architecture. You have to understand that there is multi-layered architectures which extract all the features. So here it is. This is the result. Good versus bad tomatoes. It can pick up. And this is the classification accuracy. As you can see, there are only few misclassifications. Otherwise, the diagonal terms are quite strong, which shows that the algorithm is fairly reliable. Then violence activity detection using deep neural networks. This we, from UAVs, we wanted to extend this to what we call as CCTV cameras. So that's how this project came up. And we developed a very light algorithm, because what we did with drones was a heavy algorithm. It was not still suitable for real time. So now we have made a real time algorithm using what we call as the YOLO architecture. And we tried a CNN. So we define punching and kicking in the following manner. So any such poses we detect as punching or kicking. And here it is, image from video feed, open pose, and then the CNN classifier, and then you get. So here are the results. You can see the strong diagonal values, which shows that the classification is fairly good. There are some off diagonal terms, which shows that some inaccuracy is there, but that is not too much. But with more training, they will become better. With more training, they will become better, because that is the advantage of deep learning. The more and more you use, the more and more data you give it, it improves with time. That is what is very interesting about these deep learning algorithms. I think this is another interesting piece of work we have done. This is called as tile transfer using convolutional neural network. What this means is that you have this, for example, painter like Van Gogh, for example, the famous painter. He has his own style of painting. Or even our Raja Ravi Verma, he has his own different type of painting. Or Tanjavur painting, they have their own style. So now if you get all that type of paintings they have done and trying, and then give a different photo to be painted as per that artist, that can be done. That is called style transfer. And we'll show you some result. Now, what we have used is a very particular type of convolutional neural network, which has 19 layers deep, which can extract several features. Don't bother about this architecture, but you see, this is the right side top. This is the Van Gogh style of painting. This is how you would paint. So now left side we are giving the image of a dog. How Van Gogh would have painted this? You can see the bottom picture. So this is not, the bottom picture is not what we have painted. This is actually painted by the machine learning algorithm. That is what we have to note. So several questions will come here based on the AI and ethics. Well, by itself it is a large area, but my intention is not to go deep into such things, but trying to tell you what are the possibilities of this deep learning and mimicking some of the artists. Not only that, people are also trying to compose music. For example, you can train giving all the notes that that are composed by, for example, A.R. Rahman. Then you give your own song. Then how would it be with A.R. Rahman's composition? That can be generated. There is a possibility. Whether it is ethical, not ethical, that's a different issue. There are a lot of, in fact, there is a journal on AI and ethics. people are highly concerned because AI can intrude too much into a lot of these things. So you can see, you can create one of the postures, yogic posture. How would it look? You can see here another example. Left side top, this is the Leonid Afremov style of painting. Suppose a posture like this, which we call as the Ardha Chandrasana. I am telling the name of this posture because Vijayawada, I do come to visit this IIT Newswind. They have a big group on yoga. My friend Satya Sridhar takes care of all that, and that's how I am showing. So if this posture is painted in the style of Leonid Afremov, how would it look? That's what you can see here. So this is a very interesting application of the deep learning. So this is the variety of deep learning architectures. We'll break from this and just look at what we do in the UAV lab. We do some outreach programs. We do go fly. Okay, then we also go to schools. We do some chocolate dropping in schools to enthuse them. Wherever we go, we try to train students. Maybe on some occasion, we will come to your college to educate you. These are some of the laurels to our lab from the media and the government. So thank you very much, because I have one more presentation if time permits. And if you still have the interest, I will show you on what we have done on satellite images. I'll quickly go through that, I think. You are able to see these slides?
We see the old one. Thank you. Yeah, now it has come. Yes, sir.
Okay. Now why I'm showing this is we have used several these nature-inspired optimization methods in image processing. I'll show you a few of them. One is the image registration. Why image registration is needed is when you take two images from two different satellites, you want to merge them together to do any chain detection, etc. Therefore, image registration is important. We have done that automatically using some of the nature-inspired techniques, especially for flood monitoring. We have done. I'll show you the results only. The floods that occurred in 2009 in the Krishna, in fact, Mantralayam and some part of Andhra, they were affected. So we have done that. I will not explain the details. You can go through this paper and find out. So what we used is called as the Gini expression programming to detect the regions of flood. Okay, then crop stage classification is another important thing. What stage a crop is in. This will be of interest to the government in deciding what is the type of yield when the yield is expected, whether the crop is growing properly or not, any actions need to be taken. So for this, we use what is called as hyperspectral data. Hyperspectral means there will be 255 bands of data, and you cannot use all the 255 bands. You have to do what is called a dimensionality reduction. The 255 bands is too much to look at. Therefore, dimensionality reduction is done using what is called as principal component analysis. Then we have developed several unsupervised classification algorithms. I'll just show you some of the results. Here it is, the emerging, mature, and milking stage of the crop. We have been able to detect with fairly good amount of accuracy. We have published all these things. So stage 1, stage 2, stage 3, how what bands need to be. The reflectance, actually the wavelength will tell you what bands need to be considered. You cannot consider all the bands. It's not necessary. Then land cover classification using various algorithms we have done. So you have a image data. This is our Bengaluru region, Alsur Lake. It's a huge area, very big area, several kilometers. You can do the classification, identify what is the vegetation, water, road, urban, shadow, barren or wasteland here. So we have used what is called a glow swarm optimization technique. This is also a nature inspired technique. They are all some way related to deep learning, because here also just like deep learning is based on the way humans think, these algorithms are based on the way the animal world behaves. For example, glowworm, you have seen that small worm which will emit light when it flies. So it's based on that. And then, of course, other algorithms. We also used the Landsat data. Then we have also used the mineral mapping in Rajasthan. I'll show you the result. Yeah, this is in the Rajasthan area, the minerals, how to extract. Then even on the moon and the earth, what we do is we don't use RGB, because their RGB will not work. This is the active sensor. This is you have to have the incident light and reflected light. The reflected light is what the satellite captures. It's called as the synthetic aperture radar or the microwave image. So how, depending upon the mineral, the reflectance patterns will be different. You can see wavelength versus what is the reflectance here. For various minerals, the reflectance patterns are known. Now, once you capture the reflectance pattern, can you classify what image it is? So long back, I think in 2000 something, 2000, maybe 2000, the ISRO and NASA conducted a aerial, which means through a aircraft, they carried the hyperspectral camera and captured the Rajasthan area. That data is available, that Everest NG data. So using that, we have done some classification on the. So it's called as the airborne visible infrared imaging spectrometer next generation. So this was a joint project between NASA and ISRO. So that data is available. Based on that, we have classified and found out what are the various minerals in the Rajasthan area. Some of the results are here. We have used extreme learning machine algorithm, which is essentially neural network for this. Then on the moon also, we have done this. On the area of the moon also, you see a lot of minerals, everything is there. But moon, the problem is ground truth is not available. We don't know what actually is there. But you can find out using some active learning techniques. Active learning means where student is also in loop, not just the teacher. Even the student is in loop, and you can find out whether using your knowledge, for example, if it is iron and titanium, normally it is darker in nature. So using these types of knowledge, and it will be brighter if it is chemically richer in calcium and aluminum. So you can get the pixel looking at their values, you can slightly help the learning algorithms to learn better. So using that, we have found out what are the type of mineralogy on the moon. There are a lot of challenges, but we have done, and these are some of the results. We were able to get fairly good accuracy with active learning techniques. Okay, then the last one I'll come to you is now we have satellite, we have UAVs. The question is, can you combine these two? The answer is yes, because satellite will give you a large area, UAV will give you high spectral signature. So can you combine? And yes, that is called a super resolution. And there also we have used GAN architectures. So UAV, you have sub-decimeter spatial resolution. Satellite, high spectral but low spatial resolution. About maximum is about 2.4 to 2.9 meter per pixel. So fusion of these images will facilitate in an enhanced understanding of the features, both visually and quantitatively. So visually, it will have all the benefits from the UAV. Spatially, I mean quantitatively, it will have all the benefits of the satellite. Then the GAN, what it will do? It will fuse these two aspects of the information that are independent into one holistic image. I should go to this. The objective is to create multispectral UAV imagery datasets, registration of these two images, and develop deep learning architecture. So you have, for example, a Sentinel data. Sentinel is a satellite which has 20 meters, 10 meter resolution of 4 bands, 6 bands are 20 meter, and 3 bands are 60 meters. Which is very coarse. And we have a UAV which can give you sub-centimeter resolution. We conducted our flight plans at Mallikarjunarao and Alappuzha. Quite a large area. We use both the GoPro camera and Red Edge camera. And you can see this is Red Edge is 6.8 centimeter per pixel, whereas Sentinel is 10 meter per pixel. But Sentinel can capture large area. UAVs cannot really capture as large an area as that, but we can combine these two to get a large area at good spatial resolution. So this, we conducted the flight campaign, we obtained the data. So now this is the whole idea. You have a low resolution image, you send it to a generator block, which is essentially another neural network. Then it will generate a high resolution image. This will be sent to a discriminator block, which will have the high resolution image. So low resolution image is from the satellite, high resolution image is from the UAV. The generator block is designed to generate a HR, a high resolution image, and this high resolution image should match with UAV image. So this is what the discriminator block will decide. So if the discriminator is satisfied, then that is taken as the HR or the high resolution prediction. I'll explain you what this means very simply. This is like this. There's a generator and adversarial network is something like this. Suppose you imagine that someone is faking a counterfeit note. Counterfeit note, if he has to fake, he will look at the original currency. He is the thief. He will develop a counterfeit currency. he will send it. The police has to catch. The police will see, and police will know when comparing with the original currency, he will detect, oh, this is missing. Therefore, this is fake currency. Then this information will go. The thief will use this information, again do the corrections to the fake currency, and again he will detect the. So this is the actually generator is the thief, and this fellow is the adversarial or one who or the discriminator who finds out the faults in the counterfeit counterfeit currency. So this will go on till a point when the thief, having considered all the points of the generator or the discriminator, the generator will now develop a counterfeit which no longer this policeman can detect. And then that is it. So then the counterfeit he has generated is as good as the original currency. So this is the idea even here. So you have a low resolution image. This will first generate a high resolution image. Then the discriminator will check again at the high resolution image and send the feedback again to the generator block, which will again regenerate. So this is the iterative solution till you generate, that is the generated HR image matches with the high resolution image. It will go on. So that's how it works. So we have done this. Of course, I will not discuss with other things because there are a lot of other architectural differences we have done. Unless you are into it, you will not be able to understand. But this is the overall philosophy. We have come out with our own approach as to especially how we can combine these images. And this is what the results we have got. The HR image, this is the low resolution. We combine these two, we get the super resolution image. This is for the Palakkad region. We have a lot of measures for this. The measures are the peak signal to noise ratio and structural similarity index. So any PSNR value close to 30 is good. So here is the values, and with our method we get the highest 27.32. Then again structural similarity index should be close to 1. You can see we are 0.86 compared to other methods. So our proposed method is very efficient in doing all these things. So thus in our lab, what I have shown you is that we have worked on the image processing acquired by the satellite using various techniques. We have worked on the image processing acquired by the drone. We have also worked on the methodology where you can combine the satellite imagery and the UAV imagery. So thus in a nutshell, I have tried to compile all the work that we have done. Most of these things are available on the Google. You can go and Google on my name. You will find all these related publications which should help you. I think we can now discuss if at all you have any questions. I close my presentations with this and look forward to maybe some discussions if you have. Yeah. I see something in the chat. Okay. Not much.
Sir, compared to the generative adversarial networks, how the OpenCV and Python MATLABs compare, sir, in this analysis?
See, this GAN is an architecture, while Python or OpenCV, these are all implementation protocols. For example, same thing we can implement in MATLAB or Python, the same GAN. So GAN is more like a algorithm which can be implemented in any of the platforms that you are saying. But of course, Python is preferred because it has a lot of advantages.
Sir, there are about 100 smart cities. Are they geared up to use the multiple CCTV images to instantly capture and then use that knowledge of some critical area to act upon the camera feeds? Have they come to that level of maturity or not yet?
Well, you see, current technology do permit that, whatever you're saying. So you can create a grid of CCTVs. You want to monitor, let us say, some area. We can divide the areas into subgroups, sub areas, maybe 3 streets, 4 streets, monitor them. And in case there are any instances of molestation, chain snatching, etc., immediately an alarm can be raised and some gates can be automatically closed. Police can be alerted. This is quite possible, but I am not sure whether the smart cities do cater to these things. But technically, yes, it's a possibility. I think what your question is very apt to that way. That way, it is very, very relevant. Hope if this is implemented, it will be great. But technologically, yes, we are geared up to that. There is no missing link. It is quite a possibility. Algorithms are available. It's just the question of implementation. And it will be good to do that when they plan the cities.
Thank you, sir.
Yes, sir. Anything else? I see about 54 participants.
Anybody has any final words? Unmute yourself and ask the questions.
Any discussion, not necessarily question. I've gone through my presentation just to cover a wide range of work that are possible. So in this connection, if you have any discussion points or questions, it will be good to talk to you. Is there anybody working in the area of, I'm sure image processing, somebody must be working. Yeah. After a talk like this, silence is no good.
No queries from the participants, sir.
Okay.
Thank you so much, sir. Thank you for your wonderful session. Your
Thank
session
you.
has delivered a very good knowledge in UAV image processing, sir. And your session is very interactive and we have enjoyed a lot. And thank you
Thank you.
so much, sir. Even in your hectic schedule also, we have accepted our request as a resource person. Thank you so much, sir. I
Thank you.
thank all the participants for your wonderful support. And feedback link has already posted in the chat box. Please fill that. And tomorrow's session starts sharply at 10 o'clock. Thank you.